So, for example, I say that I'll try to give more and more geographical examples. Suppose I say that there is no difference between the literacy rate of two districts. Suppose I have to identify that whether there is any difference between the literacy rates of two districts A and B. So, as I have not yet conducted the experiment, not yet conducted any kind of statistical observation, so literacy rate, that there is no difference between the literacy rate of the two districts, is that what we know so far. And alternative hypothesis is that I am deducing something and finding out and stating that yes, there is difference between the literacy rates of the two districts. So these two hypotheses, first of all, they are mutually exclusive. That means when one is correct, other is incorrect. Both cannot hold true at the same time. So therefore, by applying certain techniques, certain tests, we are going for null hypothesis and alternative
Ah,
hypothesis. So we are going for hypothesis
mamuri
testing.
khabuna.
So there are certain types of variables. Once again, I will not go into details. The variables are two types: qualitative and quantitative. Qualitative variables are broadly divided into two categories: dichotomy. That is, for example, if there is only two possible outcomes. For example, marital status. Either you are married or you are not married. And on the other hand, you have the polynomial qualitative variables where there are five categories of nominal variables. For example, religion, mother tongue. On the other hand, you have quantitative variables which gives you the discrete and continuous data. Discrete data is they cannot take any kind of fractional values. For example, children in a family, number of El Nino years. Continuous, you have rainfall, elevation, etc. So there are four various kinds of data or scale of measurement. Now, why it is important? Because based on my data set, it will determine what kind of statistical technique I will use. So nominal variable is the first kind of such variable which consists of categories in which there is no order, no hierarchy. For example, I say that the mother tongue is either Bengali or Hindi or English or Assamese. So please note that these outcomes, there is no hierarchy among them. I cannot say this is high and this is low. So this is nominal. On the other hand, you have ordinal data where there is rankings, ratings. For example, good to poor, so excellent to poor. So these are ordinal data. Now you have interval data where there is a numerical data is required, and first of all there is an arbitrary zero value. So what does it mean? It means, for example, I say 0 degree Celsius. Now, Celsius is a unit of temperature. Uh, we know there are various other units of temperatures: Fahrenheit, Kelvin, etc. So, 0 degree Celsius doesn't mean 0 degree Fahrenheit or 0 degree Kelvin. But on the other hand, if I say that the length of a line is 0 meter. Now, if I say 0 meter, there are other units of length, such as centimeter, such as millimeter, kilometer. So 0 meter means 0 kilometer, 0 kilometer means 0 centimeter. So whatever. So this is interval scale, and the next is ratios. So interval scale is one where there is arbitrary zero. That is, I have taken something as 0 degree Celsius, but that doesn't mean that this is absolute zero. There, it doesn't mean 0 degree Kelvin. It doesn't mean 0 degree Fahrenheit. On the other hand, for length, you have the ratio scale where 0 meter means it's non-arbitrary 0 point. Uh, it means 0 centimeter, 0 millimeter, 0 kilometer, whatever. So this gives us an idea about how I numerically present quantitative data. So, for example, for this purpose, you have uh, Acha, so I think now the slides are running smoothly. So far I did not get any information. So, anyways, so as I know that how I'll numerically present quantitative data in the form of frequency distribution. Here what happens, an ungrouped or raw data which is measured in a quantitative scale is now categorized into various classes for frequency distribution. So this is the basic idea of how I arrange the data into various categories, arrange of course quantitative data. Now there is a basic science behind the construction of a frequency distribution. So here we all know about the Sturges rule. Suppose I have a number of ungrouped data sets. I have a number of ungrouped data. So before going to that, we have to determine into how many classes we can arrange the data. So there is a formula for that. N is equal to 1 plus 3.322 log capital N. Here N is the number of classes and capital N is the number of observations. So whenever I get an ungrouped data set or raw data, we directly use the Sturges rule on the basis of number of observations. Suppose I have around 40 data sets. So I can take the value of log of 40 and which comes out to be, I think, I'll just check and tell you. Around 4. So I can get roughly the number of classes in which the data can be arranged. However, we need to remember one thing. Always Sturges rule is not the only scheme. Sometimes there are some problems. I'll just come to that. So so suppose I get the expected number of classes value, and then the next step is to determine the size of each class. That means for this purpose, what I do, I get the highest value and the lowest value, and take out the range, that is highest value minus lowest value. So that value, if I divide it with the expected number of classes, I get the idea of the size of class. And then the lowest point is the starting point of first class, and then I get the lower class limit and upper class limit, and this way I continue till the value. So sorry. So then I use the tally about number of observations which are falling in each class, and then I prepare a frequency distribution table. But one thing we have to understand here, in statistics there is a term called null set. Null set means suppose a particular class has 0 observations. That means the frequency or the number of observations in that class is 0. So it is very much undesirable to get a null class. So although we have been specified to use Sturges rule, but suppose Sturges rule gives you a maximum of gives you a total of expected 5 classes. So anywhere between 4, 5, 6 is acceptable. So it is not so much exact. And then I prepare a table. So as you can see in this next slide, I divide the income into various frequency classes, and from that you get the cumulative frequency. I will not go into detail because I expect you know. This is the histogram, this is the frequency polygon, and this is the ogive. So histogram is a basically two-dimensional area diagram which is taken by which is drawn by taking the income in x-axis and frequency in y-axis. So the midpoints of histogram are drawn in the form of a polygon known as frequency polygon, and then you have the ogive which is drawn against income with respect to cumulative frequency. So next comes property of a distribution, that is the central tendency. That is central tendency specifically is, I mean, the very word means the tendency of the data to occupy a particular central value. That is where the most of the data are, mean, median and mode. Variability is the spread of the data. What is the data ta kotota chhoriye ache? I mean, uh, how spread is the data? Because here one thing you have to understand. Suppose I say that the mean of a data of suppose I have around 64 grids on which relative relief has been taken up, and I get the average relative relief as 100 meter. So if I want my average or mean to be reliable, then the important condition is that the variability should be less. Most of the data should be spread around that 100-meter value of mean. So that means if my uh, uh, variability is more, the reliability of the central tendency is less. So this is inversely proportional. And on that say we have the shape of the distribution, which tells us whether my data is symmetric or whether my data is skewed. So now, as we all know, that important measures of central tendencies mean basically it gives the idea of average score, and the reliability of the mean, as I told you, depends on the dispersion techniques. So one of the important disadvantages of mean is that it is very much affected by the extreme observations. For example, I have five values. Let us assume that the values are 5 meter, 10 meter, 7 meter, 8 meter, and another one is 100 meter. If I try to carry out the, if I try to carry out the mean, I will get somewhere around 20 or 30. So please note that here, instead of, although the four values have come up to be less than 10, only one value, which has come up to be 100, has actually dragged the mean towards unnecessary towards a high value. So this, when I say that the mean is around 25 meter, that value is not reflective of the majority of the population. Now, why is it so? Because mean is very much affected by extreme observations. When there is extremely high value or when there is extremely low value, mean gets uh, dragged and the reliability of the mean gets decreased. On the other hand, you have the mode and median. So mode is the one score which has the highest frequency, the most frequent score in a distribution. However, it is suitable for nominal data. For example, I am surveying on the mother tongue. I have studied around 50 households. Here I see that 40 households speak Bengali and 5 households speak Hindi and 5 households speak Oriya. So here the mode becomes extremely useful. That is, Bengali is the most frequent score or frequent language in the distribution. So apart from that, the utility of mode is very much restricted. Next comes median, which is the midpoint or mid score in a distribution. There is a value above which 50% cases lie and below which 50% cases lie. Now, as I told you, the disadvantage of mean is something that it is affected by extreme observations. Suppose let us take five values 1, 2, 3, 4, and 100. So, what is the mean of such a distribution? 1, 2, 3 means 6, 10, and 100. Actually, 22 is the mean of such distribution. See, because of that 100 value, the mean gets dragged towards a value which is 22. But we know that 4 observations are below 10. So, in such a situation, I will go for median. I'll arrange the distributions in an I'll arrange the observations in an ascending order, and from that basis, I will take the midpoint. So since there are 5 observations, the midpoint will come at 3, which 1, 2, 3, 400. So 3 is the median. So which will be more reflective of the distribution. So based on my data set, I will be in a position to determine the most suitable measure of central tendency. Now quartiles. Sometimes it is necessary to divide the distribution into various halves. So in this case, quartile, decile and percentiles are very significant. Quartile is the uh, is basically the quartiles are those values which divide the distribution into 4 equal parts. Suppose the distribution is 100%, 4 equal parts money, they are equivalent to 25% each. Now there are n plus 1, so so in that case, you have 3 quartiles. You have 3 quartiles. So Q1, that is first quartile, which encompasses 25% of the observations. So it is written here n plus 1 by 4. Suppose there are 10 observations, 10 plus 1 by 4. So Q2 is the second quartile, which encompasses 25 to 50% of the observation. Q3 is the third quartile, which encompasses 50 to 75% of the observation. So basically, this gives you an idea about how the distribution can be divided into 4 equal parts. Next, you have decile. The very name suggests that decile is one which divides the distribution into 10 equal parts. So there are 9 deciles, D1, D2, D3, D4 up to D9. So how do I find it out? This is the formula. So I am not going to the details of the formula. But basically, D1, that is first decile, divides the distribution into 10%, second D2 20%, D3 30%, till D9, which gives you up to 100, 90 to 100%. So there is a formula. Di is equal to L plus H by F minus into 1 by In by 10 minus C. So what is the basic idea? Suppose I have a distributed group data. So first of all, I will calculate the total number of observations, that is capital N. So capital N, suppose it has given us 100. Now DI is the, I refers to the that decile which I want to find out. See, there are 9 deciles. Suppose I have to find out the D4, that is 4th decile. So here I becomes 4. So what I do is I try to find out the 4th decile group or class. 4th decile group means N is 100, I is basically the amount of decile. So here 4 into n by 10. So it gives me a value. So next on that data set, we have to find out on which class that value comes. Suppose it comes in a class, suppose 50 to 100. So L becomes the lower class boundary of decile group, here 50. H is the width of the decile group, that is class interval. F is the frequency of the decile group, the frequency. C is the cumulative frequency preceding the decile group. So if my 50 to 100 class, in that class, if In by 10 comes, so the preceding class's cumulative frequency becomes C. So on that basis, I get the value of D4. In this way, for each decile, we are in a position to get the value. Now, next you have percentile. Now, percentile is basically a distribution which divides the, percentile is a value which divides the distribution into 100 equal parts. So that means if the entire part is 100%, so one equal part will be 1%. So this way it will continue. But the biggest applicability of percentile is the percentile rank. Now, why do I say so? Suppose many of us have seen that we use the CAT, many of us have also given the CAT test for getting admission into MBA. Now, in CAT, your result is is given as percentile. Suppose I get 89 percentile. So what does it mean? If my percentile rank is 89, that means 89% of all the test takers, of all the people who had given the examination, are below my obtained score. So this is the biggest applicability of percentile rank. So these are the various measures of central tendency. Now the various measures of dispersion, as I have told just before, that dispersion are the, they explain how widely scattered the individual scores are. And as I told you, mean and dispersion are inversely related. If the mean, if the dispersion measures are high, for example, standard deviation is high, it means that the reliability of mean is compromised. That means here what is important here is that how far or close to mean the individual scores are. And as you can understand that they are not applicable for ordinal or nominal scale, they are usually applied for interval or ratio level measures. Next, what are the various estimates of dispersion? First of all is the range, the most simple measure of dispersion, which is the difference between the highest and lowest scores in a distribution. But you understand that it is not very suitable, not very reliable, because on it, out of the entire data, it takes only two values, which is very much uh, uh, insufficient. Sometimes we use another range called interquartile range. What does it do? It basically takes the third quartile just discussed earlier and the first quartile and gets the difference, and that difference is divided by 2. So that is also the problem here, is that we take Q3, we take Q1, we differentiate them, we take the difference between them. So the upper 25% scores of Q1 and the scores above 75%, that is Q3, are ignored. So basically, I am working with only 50% of the data sets. So semi-interquartile range is not so suitable. However, the most suitable measure is the standard deviation. Now, what does it take? It takes into consideration all the observations in the data set. And since we have calculated the arithmetic mean, so for the deviation or the distance of each observation from the arithmetic mean is taken up, and now the problem is that some observations are above mean and some observations are below mean. So if I take observation minus mean, it is possible that we get some positive values and we get some negative values. In order to remove the bias that may be encountered due to this positive and negative values, we square it, because you know that the square of plus 2 is 4 and minus 2 is also 4. So that squared data for each observation is then summed, and from that, if I divide it by the total number of observations, then I get standard deviation. Then I get is a parameter called variance, and square root of variance is the standard deviation. So, and in this next slide, you have some information about variance. That is the average of square distance of individual points from the arithmetic mean. প্রতিটা পয়েন্টের আমি মিন থেকে বিয়োগ করে সেটাকে স্কোয়ার করে যদি আমি অ্যাভারেজ বার করি, সেটা হচ্ছে ভ্যারিয়েন্স. So the square root of variance is the standard deviation, and I hope you know that high variance means higher standard deviation, that means higher dispersion, that means data is more spread. So it means that the scores are more far away from the mean, and low variance and mean is more unreliable, and low variance means the scores are close to mean. So this is the variance. Next, you have coefficient of variation. So basically, it is a relative variability measure. It is the ratio of the standard deviation to the mean into 100. That is standard deviation by mean into 100. So it is expressed as percentage. Next comes skewness. See, there is a concept in statistics which is said as normal probability distribution or normal curve. So normal curve is something where there is very less spread of data. That means that there is very less difference between mean, median, and mode. This is the ideal case, because if I get an ideal case, this means that that the mean is extremely reliable. Most of the observations are concentrated near the mean, and when I use this normal distribution, it means that there is very low difference between mean and median. Now, but in reality, this is not the case. In reality, we get there is a in reality there is a thing which where either the distribution are more or less higher than the mean, and or the distributions are more or less lower than the mean. Then comes the question of skewness. See, this curve, as I told you, this curve is a normal distribution curve. Here, the peak is observed around the mean. But in reality, many of the distributions are either this diagram or this diagram. Here is a concept of negative skew, where you see the mean value is the one which is cutting the line. But the number of observations above mean are very less as compared to the number of observations below mean. This is called as negatively skewed, and the reverse is positively skewed, where the number of distributions above this line or above mean are more than the number of distributions below this line or below mean. So therefore, there are two kinds of skewness: negative skewness and positive skewness. Another concept is the shape of the distribution, that is unimodal or multimodal. If there is only one mode, it is unimodal, and if there are more than one modes, it is multimodal. This is very rare case. So as I told you, if the mean is greater than mode, the skewness is positive. If mean is less than mode, the skewness is negative. And if mean is equal to mode, the skewness is 0. So you see the positive skew and negative skew diagram, as I told earlier. So there are certain formulae for getting the values of skewness. So these formulae are given in detail here. Pearson's coefficient of skewness is the most popular formula, and others are there. So since due to lack of time, we are not in a position to work, but I hope you suppose you have a data, you can calculate the mean, you can calculate the mode, you can calculate the standard deviation. So the amount of skewness you can identify. So next comes is the pickedness of a data, which is called as kurtosis. See, in this diagram, you see there are three kinds of curves: leptokurtic, normal curve, or mesokurtic, and platykurtic. Now, the curve which is very much picked, it is called as leptokurtic curve. That means there is extreme pickedness in the data set, and normal is lower pickedness, and platykurtic is very low pickedness. So this is what I have said, the definitions. So I'll directly go to the next slide. So there is a value. So what you can do is you get the uh, kurtosis value. So there is a formula. Beta 2 is equal to mu 4. Mu 4 is for each observation, I get the value of mean. Then from each observation, I subtract the mean and raise it to the power of 4. That is basically mu 4. And mu 2 square is basically the variance. That is x minus x bar whole square. So if I get the ratio, I get this value as measure of kurtosis. So if the value of kurtosis is greater than 3, the distribution is leptokurtic. If the value of kurtosis is less than 3, the distribution is platykurtic. And if the value of kurtosis is more or less equal to 3, the distribution is normal or mesokurtic. So this is all about descriptive statistics. Now comes the inferential statistics. So when I say inferential statistics, that means I am drawing out certain conclusions from the data sets. So first of all is the scatter plot and correlation. So when there are two variables, suppose in this case you have relative relief and drainage density. These are two parameters in geographic literature. I have a sample data set for each river basin. I have the average relative relief and I have the drainage density. I want to see whether there is any significant relationship between these two parameters. So what I have to do, I have to take a two-dimensional graph paper. And on that, I have to plot the data taking in x-axis, we decide on which is the independent variable, and on y-axis, we decide which is the dependent variable. From our geographical knowledge, we can understand that relative relief is the independent variable and drainage density is the dependent variable. So on x-axis, I have taken relative relief, and on y-axis, I have taken drainage density. So this diagram is called as scatter plot. And scatter plot helps us to quantify the degree of relationship between the two variables. So that degree of relationship is measured by an unit called correlation coefficient, which measures the degree of relationship, and it exists between +1 and -1. Now this sign is very important. Suppose I get a correlation value from 0 to 1 that is positive, that means it is a positive relation. Positive relation means suppose the one parameter is increasing, the other parameter will also increase. For example, in this diagram, there is a positive relationship apparently between relative relief and drainage density. That means if relative relief increases, the drainage density is also increasing. And when I get the correlation coefficient as negative, it means a negative correlation. That means if one variable is increasing, the other variable decreases. So, so these are the very basic diagrams. See, in this first diagram, you see that all the points are lying in a single straight line and increasing from low value to high value. It represents perfect positive correlation. The R value is +1. So, as one event increases, one parameter increases, other parameter exactly increases. In this second diagram, you see, although there is an apparently a positive relationship, but these points are not exactly on a straight line. We say that it is somewhat weaker relationship. In the third diagram, you see there is no looking in and there is no apparently relationship. So it's a zero correlation, and the opposite is negative correlation, and ultimately you have a perfectly negative correlation. So this is a basic scatter diagram. These are the formula. See, I will be giving this PPT in PDF form to the organizers. So I do not, since I do not have time, so you can easily get the values of formula for here. So what is important here is that what are the factors that affect the R? R is the basically Pearson's correlation, or you can say correlation coefficient. Because on the basis of R, you say that whether there is any relationship. First of all, the first important factor is the range. See, if the data has a huge range, that is the difference between higher values and lower values, or I may say if the data is very spread, the level of R goes on decreasing. Second is whether there is any linear relationship or non-linear relationship. Now see, there are certain cases where there is more than one trade. Suppose in the diagram which I showed just earlier, the relationship between relative relief and drainage density, there was only single trade. However, there are certain cases where I may get more than one trades. For example, if I see the relationship between soil pH and crop productivity, as we all know that the pH of a neutral soil is 7. And uh, when I say that the soil is neutral, first of all, the crop productivity is extremely high. So when the pH increases from 7, 8, 9, 10, whatever, the soil becomes alkaline and the productivity decreases. Similarly, when the pH becomes less than 7, once again the productivity decreases. So if I take the pH of a large number of soil samples and see the range, suppose it exists from 3 to 12. So when the pH, first of all, from 3 to 4 to 5, as I approach 7, the productivity increases. So initially it is a positive trend, and as I go away from 7, once again the productivity will decrease. So I get a negative trend. So basically there are two relationships. This is that in this diagram you have the left performance is performance and amount of anxiety. That can also be done. Low anxiety means your performance, because if you are not at all bothered about your examination, so it's expected that you are not sincere, so your performance will diminish. So as your anxiety increases, yes, up to a certain point the performance will increase, but too much anxiety will again cause a drop in performance. So this is what I was telling, non-linear relationship. Okay. So when there is non-linear relationship, of course, it will be very difficult to get the value of R. So another thing is the heterogeneous samples. Suppose there are in the samples of height, I take both men and women. So normally it is expected that the category of individuals should be same, should be homogeneous. When heterogeneity comes, there is also the R getting affected. Another thing is outlier. I'll just come to it a bit of moment. See, you see the as I told you about non-linearity. Here you see heterogeneous samples. Here I have taken a number of students and calculated their IQ tests and calculated their IQ. So I have taken all the students. Some are poor in IQ, some are excellent in IQ. So this is a heterogeneous sample. The third is outlier. Here you see that there is a relationship between X and Y. But one point is located at a very, very far distance. So which has got no relationship with other values. So this is basically a statistical outlier. So the next aspect is linear regression. So when I use linear regression, I basically find out the nature of relationship, and it helps us in prediction. Suppose I take the same diagram, relative relief and drainage density. Here these are the scatter plots. Here these are the scatter plots, and I have fitted a straight line. Any straight line in a two-dimensional axis is in the form of y is equal to a plus bx. X is the independent variable, y is the dependent variable, b is the slope or the rate of change, and a is the intercept, that is the value of the value of uh, y when x is equal to 0. So there are some process, and basically this is the equation. Y is equal to 0.004x plus 2.009. So now for any value of relative relief, I can get the value of drainage density by just substituting the value of relative relief for x. So this helps us in prediction. However, if I compare the predicted value with the actual observed value, it is not necessary that the predicted value will be exactly equal to the actual value. So this gives some kind of error. It is known as y minus y crow, where y is the observed value, y crow is the expected value. This is called as error of estimate or residual. Now, if I want my relationship to be more reliable, then my idea should be to ensure that this error of estimate to be as low as possible. So we have to summation this y minus y crow, and it should be lowest. Now there are between these two lines, these two parameters, relative relief and drainage density, a number of lines are drawn. Since our objective is to reduce the number residuals or the summation of y minus y crow, and this formula is therefore known as least square method. So as I told you, this is the summation x minus it is just a printing mistake. So it should be x minus y minus y bar y crow should be equal to 0, but it will never come to be 0. We have to get the uh, lowest value. So the method in which the straight line equation is fitted to its set of observations of x and y is known as least square method. Therefore, the regression line is the line which, when drawn through your data set, produces the smallest value of this summation y minus y crow whole square. It is also called sum of square residual or SS residual. So as I told you earlier, that sometimes there are data sets where the linear trend or a single trend doesn't exist. So in this case, we use polynomial regression. As I told you, the relationship between soil pH and crop productivity. I'll just see whether any message has come. Slide is not. Okay. So this is the curve which I have fitted. Now there are certain techniques. In fact, many of you who might have who might think of opting for masters in geography in our university or in other universities. So here we are being taught something called matrix algebra. And many of you, if you have mathematics in your class 12, you might have already done it. So from matrix algebra, there are certain steps to get this equation. Here you see y is equal to, here y means crop productivity, is equal to minus 155.26 x square plus 221.5x minus 4752.9. So this is basically the polynomial regression. So uh, this is a basic example of how nonlinear trend exists. Here you see the line is not a straight line, rather it's a curve with two opposite directions, because one, first of all, there is a positive trend, next there is a negative trend in a single data set. In geography, one of the important aspects is the question of multiple factors. See, very rarely a dependent variable is dependent on only one factor. Although I have taken up the relationship between relative relief and drainage density, but drainage density does not only depend on relative relief, it depends on various other factors also. For example, climate, for example, land use. So for that purpose, we use the multiple regression models where all these x1, x2 up to xk, there may be innumerable factors will affect y. So this is multiple regression models. So next comes multi-criteria decision making. See, the contemporary field of geography is slowly becoming more applied. So we have to we have to help the policymakers by taking certain uh, decisions. And here decision are always help us if I take a number of factors. In geography, erosion is a major problem. Now, erosion depends on various factors. It depends on topographic factors like relative relief, drainage density. It depends on climatic factors. It depends on soil factors. It depends on land use, land cover factors. It depends on vegetal factors. So many factors. If I wish to interpret to take a multi-criteria decision making, so it can be applied in geography. Suppose you see Here I have 14 river basins named as A to N. I have the relative relief, I have the drainage density, I have the slope. So there are three criteria. They can be as much as possible: relative relief, drainage density, slope. They are divided into two factors: non-beneficial criteria and beneficial criteria. Beneficial criteria means those factors which promote erosion. For example, high relative relief means higher water flow, high drainage density means higher water flow, high slope means higher water. So these are all beneficial factors. On the other hand, if you had another information on vegetation cover is a non-beneficial criteria, because high vegetation cover means the erosion will be subdued. So one of the important aspects is data normalization. See, here if you see that suppose I have taken the flood susceptibility. There are river basins. I have four parameters: relative relief, drainage density, slope, and rainfall. Now, rainfall and drainage density are promote positive factors for flood. So I have written here B, that is beneficial factors. And slope and relative relief are non-beneficial factors because they inhibit flood occurrence. Now you see these data, there are sorry, the parameters are of varying units, and the scale and range of parameters is different, where rainfall exists from what 1200 to 1500 millimeter, slope exists from 0.74 to 11.24. So the first job is to normalize the data so as to help in uh, measurement. It ranges so from 0 to 1. So there are various techniques of data normalization. First is linear normalization. Here what we do, we first take the beneficial and non-beneficial parameters. So for each beneficial parameter, I divide by maximum, and for each non-beneficial parameters, this is the formula: 1 minus value by maximum. Similarly, there is linear normalization too. So these are all various techniques. Linear normalization max mean, I prefer this. What I do, for each parameter, I take the difference from the minimum, and then this is ratioed against the difference between maximum and minimum. So x minus x mean divided by x max minus x mean. So this is the beneficial parameters, and this is the non-beneficial, that is maximum minus value divided by maximum minus minimum. So these are the formulae. So this way you can get the linear normalization max mean, you can get the linear normalization sum. So there are various, as I told you, there are various parameters. Next, there is vector normalization, enhanced accuracy normalization. So these help in basically giving us the normalization technique. As I told you, for my own research, I specifically use linear normalization max mean. Now there are certain multi-criteria techniques. See, this is something which we as geographers face. As I told you, that a multiple factors affect a particular event. For example, erosion is affected by a number of factors. Now, what is important here is that we have to understand the all the factors do not affect the dependent factors in the same way. So it brings the question of weight. That means
I'm
I
sorry, sir.
assign.
Please, I'm sorry, sir.
Ah, yes,
I'm
yes.
interrupting you. Plus, but please precise your lecture
Okay,
because
okay,
time is very
okay.
limited.
It will take just 5 minutes maximum.
Okay, sir. Okay, sir. Okay, sir.
So this is WSM. The full form of WSM is weighted sum model, and WPM is weighted product model. So what I do, for each parameter, I assign weights and then sum to get the composite value. And for weighted product, I, instead of summation, I multiply. So weighted sum is more popular. Then next, another, there is another model, that is WASPAS. Here, both the weighted sum and weighted product are average. So I get a weighted sum composite score, I get a weighted product composite score, and then I assign weight to those two methods. Suppose I assign 50% weight to weighted sum and 50% weight to weighted product. So 50-50. Here lambda is the importance factor. Here lambda becomes 0.5. If it if I feel that weighted sum is more important, so my value of lambda will increase or decrease. Next, there is topsis. So the entire formula here, what I do from the entire data set, I get the best value and the worst value. So then this is the formula for topsis, and for best value I get SI plus and worst value I get SI minus, and this is the formula. So I'll directly go to the analytical hierarchy process, AHP. This is the most popular methods of multi-criteria decision making. So in case of flood susceptibility, in case of erosion susceptibility, in case of development, people who are interested in working on development, they can also apply. Now this is introduced by Sati in 1980, where unequal weights are assigned to the parameters. And this is the scale which is given. 1 means equal importance, 3 means moderate importance. So this is given. And we ask a pairwise comparison matrix. So for each parameter, we ask, suppose whether relative relief is more important or drainage density is more important. So I say relative relief is more important. Then I ask how much? 1, 3, 5, 7, 9. So based on my subjective uh, decision, I say relative relief is 3 times more important than drainage density. Now this is a complex thing. We basically, for this purpose, we select a number of experts, we ask them about their perception, and that helps us in giving. So this has been done as flood susceptibility analysis in the Torsha river basin of India. So these are the various conditioning factors: relatively, dissection index, slope, curvature, and annual rainfall, drainage density, stream flow. So there are around 1, 2, 4, 8, 12 conditioning factors. So there is also another method of normalization called fuzzy normalization. So this has been done. And ultimately, I have given these parameter priorities on all these based on my expert's opinion. I got 3 categories of expert: geomorphologists, geologists, civil engineers, and the fourth one is government officials. So they have given. And finally, on their weightages, we found the final flood susceptibility map of the Torsha basin of India and Bangladesh. We saw that 22% of the area is very highly flood susceptible, and we find an area that is this part. This is the foothill zone. This is the foothill zone where the flood susceptibility is high. So similarly, some erosion susceptibility assessment of the Muirakhi river basin has been also done, and this is the final erosion susceptibility. Now you see that in the middle domain shown by this diagram, the erosion is high because the topography is also showing such, and in the upper and lower domain, the erosion is low, the topography is showing such. So this is all about the quantitative techniques. So in fact, this formula can may be incorporated in your analysis, which helps us in understanding how various parameters can be applied in uh, your quantitative techniques in geography. So this is all. Thanks a lot for giving me an opportunity. So if you have any questions, please, I mean, up to you. Thank you. Thank you, ma'am.
Thank you, sir. Thank you, Dr. Sengupta. And we are much enriched by your delivery. And I think the students of geography will also more enriched by your effective delivery. Time is very limited because another session is waiting for us, but an interactive session we can make, and we can take a few questions, I again stating a few questions. And if you have any question, you can put it in the chat box.
And madam, I'll just this PDF, I'll convert it to a PDF and I'll send it to the to the organizers, so you can share it with your participants and students.
Okay, sir. Okay.
কারণ যদি বাংলায় কিছু প্রশ্ন থাকে করতে পারো, মানে খুব একটা। ওকে, okay, then I think uh, once again I express my sincere gratitude to the college authorities and organizers for giving me an opportunity to interact. So thanks a lot. I wish best wishes to all the students, all the participants, and specifically the college for taking the subject of geography forward. Thank you. Thank you, sir.
Thank you. Thank you, sir. Thank you, sir. Now we will start our second part of this webinar, and I'm paying my sincere gratitude to Dr. Mehboob Sahana, Liverhall Early Career Fellow and Lecturer in Geography, Manchester University, UK. I have stated early, so I will welcome Dr. Sahana to deliver his speech.
Thank you so much, ma'am. Thank you, all the faculty and Department of Geography, and my previous speaker, Dr. Somasis Datta. I have learned a lot from him, and I know him. Is a little bit echo from my side, or the sound is okay?
Sound is okay, sir. Okay, sir. You can
Sound is okay.
continue.
Okay. Sorry, I'm in the field work, so maybe my internet connection is not that much good, but I will try my best. So, and so is it good if okay? So okay, so I will discuss the future trends and career opportunities in geography and associate discipline. So my lecture is divided into three sections. First, I will discuss a little bit about what's going on in international level, like what trend in last 2 decades, and the skill-based trends in geography, and in India, how we can adopt this trend and how we should motivate our student to adopt this trend to grab some vocational things in geography. So I think most of the most of the participant are from honors geography, or masters is also there. Master student is there, or only honors geography, ma'am?
Uh, Dr.
Both, sir.
Both, sir.
Both. Okay. Okay. Sure. So let's talk about. There is a news in last 2-3 years back that half of Indian students have lack of skill for 21st century job. So I will discuss about in our subject in geography how we can adopt this kind of skill, and what are the new trends in geography or new skill based trend in geography, and then we'll talk about how we can learn this kind of skill, and what is the free sports, and how this can help us in the career of our Indian student. So uh, trends in modern geography. We know that geography is a fact or descriptive based subject. Previously, we thought that geography, lots of definitions is there, so I'm not going back to this kind of definition. But new trends is about interdisciplinary, interrelations based subject. So what does it mean? So we know that plant, animal, and human. These are the three important trends and three important part in modern subject geography, and how this trend had influenced the sub-disciplines of geography. That is an important area. So I know it's little bit difficult for the student, those who are in undergraduate, that okay, because I don't know how they can grasp what I'm talking about, and because uh, I will after a few times I will bit add the AI, artificial intelligence, and AI GIS. So that's why I just touch this thing, that what this trend and how this trend is associated with our discipline. Like here, in last 2 decades, we discussed a lot about contemporary geography, climate change, environmental geography, or environmental change. So like in contemporary geography of 21st centuries, so there are two things: historical geography and contemporary geography. So historical geography, that means the thoughts process of this subject, and then contemporary geography studies social patterns of comparisons originality exist. The studies landform, climate, culture, etc. That's occur on day to day basis. So like everything is changing slightly. So subdiscipline and discipline of geography is also changing slightly. So like 30 years back, when we talk about urban geography, so models, theory in urban geography have some kind of basis. But when you talk about urban geography in today's generations, like আমরা যখন প্রথমে পড়তাম ফন্থুন থিওরি, ফন্থুনের ল্যান্ড ইউজ থিওরি, বা এই ধরনের থিওরি নিয়ে আমরা বেশি ডিসকাস করতাম ইন আরবান জিওগ্রাফি। বাট নাওডেজ এখন আমরা পড়ি যে সিটি জাস্টিস ইন সিটি, বা সিটির যে নতুন মডেল, লাইক প্রাইভেট সিটি, প্ল্যানেটারি আরবানাইজেশন, দিস কাইন্ড অফ ট্রেন্ড occurred in subdisciplines of urban geography. So এই যে ট্রেনটা আমাদের সাবজেক্টের মধ্যে আছে, so we have to understand this trend in every subdiscipline, and then we need to go for the skill. So আমি দুটো জিনিসকে মার্চ করার চেষ্টা করছি for your understanding that আমি কি বলতে চাইছি এই সাবজেক্টে। Now contemporary geography subfields urban geography, its fragmentation, and how it associates with other subdiscipline and sub area of geography. So here is a picture like urban geography, and it's have some fragment, quality of life, service provision. So it is subdiscipline, and then their fragment, and then how it's associated with other disciplines in geography. এইগুলোকে বিশেষ করেই কিন্তু আমাদের কেউ যদি যেতে চায় যে আফটার দেয়ার graduations or masters they want to go for research, after their graduations and masters they want to go for job, then how this subdiscipline and discipline can help them to create or to go in their future or career. So like urban geography, so there are some subdiscipline changing urban economic base, labor market, retail structures. So these have some fragments of urban geography, and it's also associated with something like marketing geography, economic geography, welfare geography, culture geography. So that means within the subdiscipline of geography, everything is linked with some real problem of our society, of our art. So this is a real problem: electoral geography, power geography, tourism geography, mobility, accessibility. So when we talk about this kind of real problem, so these things are linked with the real recent trends in geography also. So this is some books. I just want to skip these things. Now, how two important area: geographical information systems and remote sensing have changed or have contributed in recent trends of geography. With the development of new technology tools, two very important technologies that develop GIS. Everybody know that GIS and remote sensing is very new thing in GIS, but it's began in 1970. 1970 থেকে এই জিনিসটা আমাদের জিওগ্রাফিকে ইনফ্লুয়েন্স করে আসছে, বাট এই যে ইনফ্লুয়েন্সটাও কিন্তু লাস্ট 50 ইয়ার্সে অনেক চেঞ্জ হয়েছে। লাইক 30 ইয়ার্স 20 ইয়ার্স আগে, আজ 2024 চলছে, 20 ইয়ার্স আগে যখন আমরা জিআইএস এর কথা বলতাম বা রিমোট সেন্সিং এর কথা বলতাম, একটা ম্যাপ ইন্টারপ্রিটেশন লাইক এ সিম্পল ল্যান্ড ইউজ ল্যান্ড কভার ম্যাপ, সিম্পল ল্যান্ড ইউজ ল্যান্ড কভার ম্যাপের ইন্টারপ্রিটেশন ইটস কল্ড জিআইএস। বা একটা শুধু অনলি স্যাটেলাইট বেস ম্যাপ থেকে একটা ল্যান্ড কভার ম্যাপ বের করা মানে একটা 30 to 40 days or 50 days এর একটা মানে টাস্ক ছিল। বাট নাওএডেজ আফটার ইন্ট্রোডিউসিং এআই, আর্টিফিশিয়াল ইন্টেলিজেন্স, পুরো পশ্চিমবঙ্গের ল্যান্ড ইউজ ল্যান্ড কভার ম্যাপ বের করার জন্য 1 ঘন্টায় ইটস পসিবল। বা আমরা যদি এনডিভিআই বলি, মানে লাইক 15 ইয়ার্স আগের যে জিআইএস টেকনোলজি, সেখানে একটা এনডিভিআই ম্যাপ বার করতে, সে ডেটাকে এক্সট্রাক্ট করে, তাকে সে ডেটাকে পলিশ করে, প্রসেস করে, কাট, তারপরে the area of interest বের করে, and then when you perform NDVI model through the old software, it's like 7 days work for a single area, like a single river basin, single district or block. So it's like 5 days work. But nowadays, if you know the trend, then you can perform 6 months of NDVI every day, getting the data from cloud, and you can process the NDVI, normalized different vegetation index, of West Bengal for 6 months in a graph, and it can be done by 3 hours. So that trends is very important to learn, because in 2024, if you able to produce only NDVI by using the old methods, then it's a backdated approach, backdated model, or backdated techniques. Then you will not get a job in contemporary GIS market. So methods and machines. So we talk about GIS, remote sensing, and how GIS, a contemporary GIS, is developing in every 5 years with some new trends, new techniques, new methods, and new way. So new geography, methods and machines: map making, remote sensing, computational analysis, geographical information system. I'm not getting more detailed here. Same definitions. I mean, definition যাচ্ছি না, because I hope that everybody know the distinction between remote sensing, GIS, and GPS. Just one example, GPS. If we talk about GPS, every day, those who don't know what is GPS, like we know everybody is using WhatsApp nowadays, and a very common man using WhatsApp locations to see, like a very ordinary man send their locations to coordinate his friend in somewhere in Bardhaman, in somewhere in your place, like, oh, I'm here, can you please come here? But they don't know about background of this GPS functions, but they are using GPS. So why I'm talking about this, the applications of GIS, remote sensing, and GPS is very broad and very towards the very ordinary and common people. And now like we talk about GIS, remote sensing and GPS, but it's have a systematic background or science. It's called geoinformatics. Geoinformatics is a branch, is a, like, you can, somebody says, okay, it's already become a discipline. So no, it's not a discipline. It's associated with other subject, and it's just helping disciplines. We're not going with all these debates, but I will say geoinformatics have some elements: remote sensing, GIS, photogrammetry, cartography, digital cartography, global positions, GPS, CAD, geodesy. I hope in your honors, in your masters, those everybody have learned a little bit about all these 4, 5, 6 important area, and they learn these things. Now, little bit back, I was talking about every discipline and sub-discipline is changing every 5 years, and it's happening in every subject, not in our geography, but also in bioscience, also in physics, also in chemistry. So what we are learning in our syllabus, okay, that's a good thing. We're learning in our syllabus, and geography syllabus in West Bengal have some kind of different than geography in Australia, geography in syllabus in maybe in Middle East, geography syllabus in USA, geography syllabus in UK. So, but job market, so job market, I'm talking about the commercial job market. I'm not talking about the job market which we are used to, like after a geography masters or graduations we have to go for teaching. I'm not talking about this kind of job. I'm talking about job market. Like I'll give some example after in the end of my discussions, end of my lecture, that from here, like if people are sitting in Birbhum, from Birbhum, how you can get it, how you can work for a company in USA, how you can work for a company in America, if you have this kind of skill and ability after your graduations and after your masters. And I'm not joking, I am very serious. Many people are doing this kind of work from West Bengal and from very, very remote part of West Bengal. So you have to do, or you have to learn, adopt this skill, this setting, or this informations. Then obviously after a little bit practice, after a little bit online performance, you can do, or you can apply for job in international market. So yeah, here is a picture, like why from 20 minutes I'm talking about skill, because in 2010 you can see say image like this man is capturing a photographs of a mega event, like a event by any mantri or minister. So just 10 to 15 years back, this kind of techniques was adopted. But after innovation, after the drone technology, nowadays a simple reception, একটা বিয়ে বাড়িতেও এখন ড্রোন টেকনোলজি ইউজ করা হয় টু শুট দ্য ম্যারেজ থিংস। সো ইভেন আমরা যদি দেখি যে 20 ইয়ার্স আগে আমাদের গ্রামগঞ্জে বা আমাদের বর্ধমান বা আপনাদের ছোট ছোট মফস্বল জেলাতে সিডি ক্যাসেট একটা বিশাল চলন ছিল। সিডি ক্যাসেট মার্কেট ছিল বা কোডাক ক্যামেরার মার্কেট ছিল বিশাল, এবং সেইগুলো হয়েছিল ওই জায়গার সব থেকে প্রফিটেবল বিজনেস। বাট if you go to this shop, this area, সেই সিডি ক্যাসেটের দোকানগুলো বা সেই কোডাক ক্যামেরার দোকানগুলো নেই। সে কিছু মানুষ অ্যাডাপ্ট করেছে। তুমি যদি সার্ভে করো তোমার জাস্ট ইন ইউর এরিয়া, তুমি দেখবে যে সেই সিডি ক্যাসেটের দোকানগুলো যারা নিজেদের ইগোকে ধরে গেছে, না আমার সিডি ক্যাসেটের বিজনেস সব থেকে বেস্ট, আমার কোডাক ক্যামেরার বিজনেস সব থেকে বেস্ট, আমি চেঞ্জ করবো না আমার নিজেকে, তারা কিন্তু হারিয়ে গেছে মার্কেট থেকে উইথ অনলি 10 to 15 ইয়ার্স। বাট যারা অ্যাডাপ্ট করেছে এই টেকনোলজিক্যাল ট্রেন্ডকে, যারা অ্যাডাপ্ট করেছে মার্কেটিং ট্রেন্ডকে, তারা টিকে আছে সেই মার্কেটে। সো ইফ ইন ইউর স্মল মার্কেট, ছোট্ট গ্রামের মার্কেটে যদি এই ধরনের ট্রেন্ড থেকে থাকে, তাহলে হোয়াই নট ইন আওয়ার সাবজেক্ট, হোয়াই নট ইন আওয়ার ডিসিপ্লিন, যেটা আমরা আমাদের জীবনের কেরিয়ারের জন্য বেছে নিয়েছি, হোয়াই নট ইন আওয়ার ডিসিপ্লিন। and why আমরা কেন এই জিনিসকে লার্ন করবো না? So geography and environmental change, yeah, this is a very significant things, because we are living in a generations in a age of climate change. It's a global acceptance, মোটামুটি এটা সবাই মেনে নিয়েছে, এবং এই not our subject only, our economy, our politics, our social things, social change, everything is depend on climate change, climate theory, climate policy, and it is a very, very significant part of our life. So we cannot ignore climate change, we cannot ignore environmental change, and in your subject also. That means if you're interested in human geography, if you are interested in social geography, you can also link climate change in your core subject. Maybe sometimes you no need to adapt climate change, no need to no need to integrate climate change in your research or in your study, but you should at least accept these things. Okay, now I'm entering big data, machine learning, AI, and artificial intelligence. So, electronic space and emerging new geography of the net. একটা সময় ছিল জিওগ্রাফিকে আমরা ফিল্ডে না গিয়ে আমরা জিওগ্রাফিকে ডেসক্রাইবই করতে পারতাম না, আমরা জিওগ্রাফির কথা ভাবতেই পারতাম না। বাট last few years or 2 decades, and then pandemic happened, and then it's a post-pandemic era. How electronic space and emerging new geographic in net, like virtual space, big data, and virtual things, how contributing in your subject. I'm just giving one example, like I was talking about some people, like suppose in Bardhamane, I think 10,000 shop ache, very small shop, informal market, fuchka wala, chai wala, and maybe something. So everybody, this fuchka wala, this rickshaw wala, whatever the thela, so everybody have a Google Map profile. In Google Map you can find them, the locations, their area. So few days back I was in in the highway between North Dinajpur, Siliguri to Raiganj. So, and I forget to pay a thelawala just come around, and then after a few times I remember that, আমি তো চায়ের পয়সা দিইনি, and then I searched in the Google সেই চায়ের পয়সা কি করে দেবো, and তার ঠেলাওয়ালা পেলাম, তাকে তার নাম্বার পেলাম, and গুগল পেতে এই ফোন পেতে তাকে পে করলাম। So like this, like me, if মানে বর্তমানের এই যে ফুচকাওয়ালা ঠেলাওয়ালার কথা বললাম, তাদের যে ইনফরমেশন আমাদের গভর্নমেন্ট do not have this kind of information, how many fuchkawala is there, how many, there is no database, but the Google have this kind of data, and Google know এই ফুচকাওয়ালার কাছ থেকে কতজন মানুষ থ্রুআউট গ্রাম বা কোন ওয়ার্ড থেকে কতজন মানুষ ফুচকা খেতে আসছে, ফুচকা খেয়ে চলে যাচ্ছে, Google know everything. But our government don't know there is a fuchkawala, and our database system don't know there is no what is this, no evidence that there is a fuchkawala, but Google know everything. But we don't know how this data will be used in future, and they will sell this data to us, or maybe to this fuchkawala after 2-5 years, if they exist in the market, that okay, before 5 years this person came to you to grab a fuchka. So we have to adopt, we have to understand this trend, we have to understand this database, this what is this virtual space. আমরা প্রত্যেকই হাঁটছি, আমাদের সাথে মোবাইল হাঁটছে, and আমাদের সাথে আমাদের ইনফরমেশন হাঁটছে। Okay, so that is internet facts. Expansions of geographical distribution of the global net. We don't know how millions tons of data every day gathering by these big multi-million dollar companies, multi-million dollars agencies, and they are using our data, our activities, our choice, our wishes, what we like, what is dislike, when we want to eat, when we want to do not want to eat, and how this expenses or how this data, how this informations we can use in our subject. That's the questions. That's the trends in new trends in geography, and we have to think like what the geographical future is coming. আমাদের geography subject এর কি ইম্পর্টেন্স এন্ড এই ট্রেন্ডের কি প্রভাব পড়তে চলেছে। মেবি আমার কথাগুলো হয়তো একটু মানে অড অর মনে হচ্ছে, what I am talking, how I linking all this subject, maybe some time, but yeah, I'm trying. Okay, okay, আবার একটু ব্যাকগ্রাউন্ডে যাচ্ছি। why GIS, why this artificial intelligence, why this AI, why this big data, and why this internet fact. Okay, so একটু ব্যাকগ্রাউন্ড। every object on the earth can be georeference. পৃথিবীতে যা কিছু আছে সবকিছু জিওরেফারেন্স হয়, আমাদের মোটিভেশনস, আমাদের মুভমেন্ট, even the non-materials, non-living things, and it can give us answer what is at, where is it, what had changed since, what special patterns exist, and what if. So that is identifications, locations, trends, modeling, scenario. These are the 5 important W can give answer by GIS, and there is no other subject who can give the answer for this. That's why a historian now using GIS, a politician now using GIS, a political subject, political science using GIS, economists, everybody using GIS, law, and every subject, every discipline. Few days back in Manchester, one cancer scientist from in the biological science lab, they coordinate our. I was not in the team, but I know that this is happening in Manchester. So they coordinate our geography department. They are building some cancer case history, and they came to know that GIS have some ability to superimpose the layers, and they can give some result. So they are using they are adopting this kind of GIS layer-based technology, layer-based solutions, modeling in their subject. So nowadays, in cancer science also, GIS is a applicable area. So and let's give you some information about GIS software. ISRI, mapping with ISRI, manifold, internet graph, geomedia, small wall, grass. No need to give all details. Okay, now market. Which software have the highest market of GIS? ArcGIS, MATLAB, Python, C++. So I will say the student, those who are interested in GIS and geography, ArcGIS, learn ArcGIS if possible, and then Python or either R. These are the 3 binary tool which is very important, very necessary to learn to get a job in this subject, in this like modern job market. Okay, applications of GIS, there are very much applications. I'm not going more detail in all applications. Skill are with few people. Skill are with few people. Why I'm saying everybody knows GIS, but when we talk about, okay, can you able to do this kind of mapping, this kind of enable to solution, make a solution these things, they say, okay, I know these things only, I do not have the knowledge of programming. Programming is very important for this modern GIS, modern technology. GIS is nowadays taught in school, college, universities throughout the world. Professionals of many fields are getting our internet user of GIS have grown rapidly, very much rapidly, and I said that it's like in every discipline it's have some impact. Okay, GIS in decision-making tools in various sector, natural resource management, disaster management mitigations, health, education, business GIS, electoral process, environmental applications, military applications, infrastructure, power, telecom, transport, urban planning. Now, GIS applications, GIS have 5M: mapping, measurement, monitoring, modeling, management. So through all the the discipline of uh, like the whole GIS is depend on this 5M. Okay, natural resource management applications. I'm not going much details, but yeah, it's have like the modern climate science, the modern environmental change science is totally depend on GIS. The climate scientist is unable to do anything, is not capable to do anything without GIS. GIS is very dependable for this climate science and uh, climate change things. Okay, disaster management. No, I'm not going much details. Managing disasters. Why? So maybe okay. I'm in time. Managing disaster and why? So yeah, you know, uh, just one example. So everybody know that Odisha cyclone 2001, the mortality of Odisha cyclone or fatality. So sorry, is Odisha cyclone was more than 10,000, but Odisha cyclone was not that much devastated as cyclone Haila or as cyclone Amphan. Like speed was the Odisha cyclone speed was not that much high in compared to cyclone Amphan, but the casualties in cyclone Amphan is only below 50. How it's possible? Because of GIS, because of monitoring, management through the GIS, management through or real-time monitoring, real-time forecasting, and real-time mitigations. So, and this is possible through this GIS and remote sensing technology, which was adopted by in meteorological department, IMD. Okay, so yeah, managing disaster. Why? Better decisions and inform actions. Action, decision, model, analyze, measures. So I'm not going more detail. Yeah, I want to skip this. Again, forestry is an important area, application of GIS, and there is lots of job in monitoring, in disaster management, disaster science, and in forestry, agriculture. Nowadays, you know, maybe you heard that our government is also providing drone technology to our farmers, or maybe in future many GIS based development will be happen. But yeah, it's already started in our country also. But yeah, uh, the farmer have lack of knowledge how to use this drone, how to use NI technology in their crop productions, crop maintenance. But slowly it's already started, but slowly it will increase. Then maybe in every block or every panchayat, they require a GIS persons in their uh, uh, in the governing systems. So then in the job market, yeah, GIS have many area in government sector, in private sector, in public sector, in NGO. Everybody, every offices have some kind of GIS persons. Okay. Now I'm entering very complicated part of my lecture. That is today's GIS, Geo AI, and we you. What is this? Yeah, I know it's little bit tricky. It's little bit overrated. Big data, GIS, artificial intelligence, machine learning, and deep learning. So, what is artificial intelligence? Artificial intelligence, GIS or AI GIS technology is currently an important research directions which is integrated system of RS, remote sensing, AML, machine learning, and DL, deep learning. But most of the studies mainly focus on some application scenario. Till it is in developing phase. AI GIS is developing phase, but we have to understand this is the future of GIS. So, and sometimes we have used Geo AI. Okay. In recent years, AI GIS has gradually become the main focus of geoscience research and applications. Those in your seniors, they know that without Python, without R, or without some MATLAB or some hi-fi technology, GIS is little okay backdated. Like only ArcGIS or ADAS, this is the backdated software. Till it have good applications, but if you want to do some extra, some innovative, some more advanced, then you have to come this AI GIS market. What is needed for ML modeling, machine learning modeling, processing power, data methods. In the beginning of my lecture, I talk about NDPI, LULC, land area land cover, and NDPI. I said that before 15 years or 20 years, একটা LULC ম্যাপ বানাতে 15 দিন 20 দিন 1 মাস লাগতো, বাট আজকে পুরো পশ্চিমবঙ্গের LULC ম্যাপ বানাতে বা NDPI বানাতে আমার 2 ঘন্টা সময় লাগে। বাট that needs some these three things: processing power, আমার কম্পিউটার আমার সিস্টেমে যদি প্রসেসিং পাওয়ার হাই না থাকে, আমার ডেটাবেস যদি ডেটাবেস মানে পুরো পশ্চিমবঙ্গের এমডিপিআই বানানোর জন্য at least 5 to 10 TB 5 to 10 TB terabyte space থাকা দরকার। So is it possible in a laptop there is a 5 to 10 TB? No, not possible. So then what we need cloud. Somewhere we have a storage. No need to download the data. And also it's not possible to download the data with our small speed internet, slow speed internet, and also we need model. So when we talk about modern, when we talk about advanced, when we discuss about more advanced, then we need technology, we need speed, we need high capacity, we need high storage. Yeah, I understand that এই সব কথাগুলো অ্যাকচুয়ালি মানে আমি যেগুলো বলছি, গ্রামের স্টুডেন্ট তারা কি করে মানে তারা ভাবতেই পারে না যে হাউ 1 TB 10 TB কিভাবে এটা সম্ভব। বাট ইয়া, আমাদেরকে যদি মানে এই মার্কেটে বা মডার্ন জিআইএস, মডার্ন জিওগ্রাফির মধ্যে থাকতে হয়, আমাদেরকে এই জিনিসগুলো অ্যাটলিস্ট আমাদের নলেজে থাকুক, তারপরে আমরা অ্যাপ্লিকেশনস বা কিভাবে সম্ভব সেটা আমি পরে আসছি। আমি এটা একটু স্কিপ করছি, কি মডেল আছে, কিভাবে কাজ করে। এটা একটু বেশি সুপারভাইজ লার্নিং, সেমি সুপারভাইজ, আনসুপারভাইজ রিইনফোর্সমেন্ট লার্নিং একটু হেভি হয়ে যাবে, আমি এটাকে স্কিপ করছি। জিও ইন্টেলিজেন্স ওকে, তার 5টা পার্ট: জিও কন্ট্রোল, জিও ডিজাইন, জিও ডিসিশন, জিও ভিজুয়ালাইজেশন। হোয়াট ইজ জিও ভিজুয়ালাইজেশন? হয়তো কেউ জানো যে রিসেন্টলি আমাদের গুগল ম্যাপে আমরা মানে হয়তো কলকাতার কোনো একটা জায়গা তুমি ক্লিক করলে, জুম করলে, and then you can visualize the throughout the 3D, তুমি দেখতে পাবে রাস্তাতে কি আছে না আছে। It's called geo visualization. So Google have a target by 2030 they will geo visualize 2050 I think so, visualize whole world. পৃথিবীর কোনো জায়গা, কোনো পার্ট আনভিজুয়ালাইজ থাকবে না, হিডেন থাকবে না। ওকে, so that is the geo intelligence pyramid: geo visualization, geo decisions. GIS can take or make decisions through its own. Geo design, you can design many things. And geo control, you can control your business, you can control your system through like you can control your suppose you're traveling, there is a systems, you can control your journey through the geo control technology. So this is the complexity, maturity, high, low, and how it functions. And all these four things are associated, are integrated, and depend each other. So artificial intelligence and GIS platforms: big data GIS, AI GIS, new 3 dimensions, cloud native GIS, cross platform GIS. So I little bit back, কিছু সময় আগে আমি বললাম যে we need cloud for this kind of things. ক্লাউড ছাড়া আমরা এত ডেটা, এত কমপ্লেক্স জিনিসকে আমরা আমাদের কম্পিউটারের মধ্যে প্রসেস করতে পারবো না। So trilogy of AIGIS: AI for GIS, Geo AI, and GIS for AI. So and AI GIS future, যেগুলো বললাম সেগুলো অলরেডি চলছে, বাট in future there are so many what is this নতুন ইনোভেটিভ জিনিস আসছে আমাদের সামনে। হোয়াট ইজ দিস? ডিপ লার্নিং, মেশিন লার্নিং, আমরা এই নামটা শুনেছি। ন্যাচারাল ল্যাঙ্গুয়েজ প্রসেসিং, এনআইপি বা এনপিএল, কম্পিউটার ভার্সন, স্পিচ রিকগনাইজেশন, এআই পাস, অটো এমএল, এজ ডিটেকশন, এজ এআই, এগুলো হচ্ছে আরো ফিউচারে 2040, 30, 35, 40 এই ধরনের টেকনোলজি আমাদের সাবজেক্টে, আমাদের জিআইএস এ আসবে, এন্ড ইটস কনফার্ম। সো দ্যাটস ওয়াই উই হ্যাভ টু থিঙ্ক, ওকে আজকে যে টেকনোলজি চলছে, যে মার্কেটে যেটা খাচ্ছে, সেটা কিন্তু 5 বছর, 10 বছর, 15 বছর পরে খাবে না। সো উই হ্যাভ টু অ্যাডাপ্ট, উই হ্যাভ টু আন্ডারস্ট্যান্ড দিস ট্রেন্ডস, and we have to train our student to grab this kind of technology to sustain in the job market, to grab the most expensive job salary, like 5 lakh, 10 lakh salary in a month. So if you know all this high advanced technology, then it's possible from in your area, from Birbhum, from Bardhaman, or from Kolkata. Okay, applications of machine learning in geospatial science, supervised learning, unsupervised learning, machine learning, reinforcement learning. They have many applications. Climate, zone identifications, aeronatural science, land cover change detections, marine biome mapping, Mediterranean landscape dynamics, many applications. Okay. Now the last part of my lecture, career opportunities in RAGIS machine learning, what we have discussed. So why GIS? Advanced techniques, several applications, easy to get a job, easy to shift in different field, multiple scores, easy to upgrade skill, eco-friendly. Like if you have this skill, you can shift, you can switch as you wish, or you can, like, I know I have many friends in Delhi, they are working for US company from Delhi, and they have somebody left in Delhi, and they are in Canada, they are in America. They started their journey of GIS in 2010 from a very small university. Somebody from what is this, Rajasthan, Jaipur, Ajmer University, somebody from Delhi, somebody from Jamia, somebody from Terry, somebody from even from Medinipur. I know few people are in very prestigious institutions, very good in job market, and very high salary, but they are also from very like poor family, very discomfort zone, like from Medinipur, uh, from Siliguri, North Dinajpur. But those who adapt, or those who learn this new innovations, they are in a better positions. So যদি তোমরা মনে করো যে হ্যাঁ আমরা এটাকে অ্যাডাপ্ট করবো, আমরা শিখবো, and there are some area where you can learn this. Okay, I'm coming my next. So what you can do with a GIS degree: GIS technician, cartographer, GIS specialist, GIS manager. Here are types of GIS jobs and potential career throughout the world. Entry positions. This is the job market, and this is the what is this? এই ধরনের জব পাওয়া যায় throughout the world. And you know, salary, how much money you can make. I just told that even I know every month they earn 6 to 10 lakhs. এইরকম স্যালারিও লোক ছিল বলে আমাদের বয়সে, আমাদের ভারত থেকে, আমাদের পশ্চিমবঙ্গ থেকে ডিগ্রি করে যাওয়া ছেলেপুলেও আছে যারা এইরকম স্যালারি আর্ন করে ইন মানে বাইরে বসে। ইভেন ইন ইন্ডিয়ার মধ্যে থেকেও, ইন্ডিয়ায় বসেও আমেরিকায় জব করা, বা ইন্ডিয়ায় বসেও ইংল্যান্ডের কোম্পানিতে জব করা। বাঁকুড়াতেও আছে এমন ছেলে, আমার ম্যানচেস্টার ইউনিভার্সিটি হয়ে জব করে বাঁকুড়াতে বসে আছে। আমার সাথে পশ্চিমবঙ্গে জব করছে 6 জন আমার অ্যাসিস্ট্যান্ট আছে। 6 people are working with me, and I don't know many I don't know how much or how many people are working remotely in other universities, other project, or other area. So but কারা করছে? যারা একটু অ্যাডভান্স, যারা একটু নিজের মাথাকে তুলে রেখেছে, যারা একটু ইন্টারনেটে ফেসবুক, হোয়াটসঅ্যাপ, টুইটার, ফেসবুক, হোয়াটসঅ্যাপ, এন্ড হোয়াট ইজ দিস, ইউটিউবে টাইম ওয়েস্ট না করে যারা রিয়েল জায়গায় টাইম স্পেন্ড করে, তারা কিন্তু জব পায়, জব আছে। ওকে, নাও GIS market future opportunities, upgrade skill, programming language, big data analysis, machine learning, programming language, web GIS and online GIS. These are the trend. Every day, every year, the compound annual growth rate for GIS industry is increasing every year. So this is the trend of GIS, and it's a data from what is this? Global trend analysis, economic business standard something. They give this data. So, and this is a job market of GIS degree. বিভিন্ন ডিগ্রিতে কি ধরনের জব মার্কেট আছে, আমি গ্লোবাল স্ট্যাটিস্টিক্স বলছি, নট ইন্ডিয়ান স্ট্যাটিস্টিক্স। and why we are lagging behind for 20% jobs. আমার ফার্স্ট যে স্লাইডটা ছিল যে we are lagging behind for 20% job. Why? This is the questions. Because we are backdated. আমরা সবসময় backdated জিনিসকে অ্যাডাপ্ট করি, আমরা সবসময় পিছিয়ে থাকা জিনিসকে অ্যাডাপ্ট করি, আমরা মানে একদম অ্যাডভান্স জিনিসকে শিখতে চাই না, হয়তো আমাদের ভীতি বা আমরা হয়তো শিখতে চাই না, বা আমরা I don't know why, but we have to learn this, we have to adapt this advanced technology and it is free. তুমি একটু চাইলে, আজকাল চাইলে কি শেখা যায় না, ইউটিউব ইজ ইউর টিচার। যদি তুমি মনে করো যে আমার সিলেবাসে নেই, হ্যাঁ, ইউ ক্যান লার্ন ফ্রম ইউটিউব, ইউ ক্যান লার্ন ফ্রম what is this, GitHub is a very big platform, very good platform, and from GitHub you can get a job. So why you do not have a account in GitHub? তোমাদের ফেসবুকে অ্যাকাউন্ট আছে, তোমাদের ইউটিউবে অ্যাকাউন্ট আছে, বাট ইউ ডু নট হ্যাভ অ্যাকাউন্ট ইন GitHub, বিকজ GitHub থেকে তুমি জব পাবে, তোমাদের ওখানে তুমি এক্সপ্লোর করো না। আমরা ভুল জায়গায় এক্সপ্লোর করি, আমাদের ছেলেরা ভুল জায়গায় টাইম ওয়েস্ট করে। বাট ইফ ইউ হ্যাভ নলেজ, আজকের দিনে তোমরা, তোমাদের সামনে পৃথিবী আছে, গ্লোবাল সিস্টেম আছে, ইন্টারনেট সিস্টেম আছে, ডেটা আছে, you can use your data, you can earn it from your home, and you can, I hope you can do ArcGIS, ADAS, NB, QGIS, practical old software. These are the old ArcGIS, ADAS, NB, QGIS, old software. Need to enter programming language Python, Java, and RStudio, MATLAB with this old software, not forgetting this old one. But in QGIS also so many development happened in recent year. Okay, now this is challenges of GIS. এত কিছু বললাম positive things, but it's have some negativity, it's have some drawbacks, it's have some limitation. More investment in GIS data and GIS, better decision making, more GIS users, better data, এগুলো দরকার। And then limitations of GIS, major challenges of GIS technology. These are the limitations. এই ড্রব্যাকস আছে কিছু, এই ড্রব্যাক গুলোকে মানে ওভারকাম করা দরকার, বা এইগুলোকে মনে রাখা দরকার। আদারওয়াইজ কোন ফেসে যায়, মানে মানুষ এত বেশি ডিপেন্ডেন্ট হয়ে পড়ে কম্পিউটারের উপর, সিস্টেমের উপরে, ডেটা লস হতে পারে, ডেটা কোলাপস হতে পারে, হার্ড ডিস্ক কোলাপস হতে পারে, লার্জ স্টোরেজের কোলাপস হতে পারে, বহু কিছু করতে পারে, এতে হিউজ লস হতে পারে। সো ফ্রি ক্লাসেস, আমি এত কিছু বললাম যে এই হয়, ওই হয়, বাট ইয়েস, আই আন্ডারস্ট্যান্ড ইউ পিপল আর সিটিং in Birbhum, or maybe in Bardhaman, or maybe in Murshidabad, or maybe in somewhere. But how you will learn? US Geological Survey, they have free classes, they have free courses. This is the link, you can learn from US Geological Survey classes, free classes. University of South Carolina, they have free classes. Introduction to ArcGIS have some free classes. Pennsylvania Special PASDA have some free classes, some course. Trimble, some course, some free classes. NCGIA have some good courses and free classes. Canada Center for Remote Sensing, they have also some free classes, some courses. Free classes, remote sensing. These are the free classes. Here you can understand, learn the modern technology, modern changes, modern trends in GIS, what is going on within this subject, within this sub-discipline. GIS course in India, these are the reputed universities in India, but apart from this, there are other institutions. Some premier employer are geoinformatics centers, university. This is the premier employer in global arena. পৃথিবীতে এরা reputed companies, reputed agencies, they are employing the GIS expert. Companies providing jobs opportunities in India, these are the few companies, but many, I think more than 1,000 companies, even in Kolkata, more than 1,000 companies is there. Okay, So few are very big reputed, few are very small, but yeah, there is a job. If you have ability to work, but as I discussed earlier, আমাদের সময়ে যখন আমরা জিআইএস পড়েছি, আমি 2010-11-তে জিআইএস পড়েছি, সো অনেক ভালো স্টুডেন্ট ছিল তারা, কিন্তু ওই যে ট্র্যাডিশনাল জিআইএস, আমরা আরজিআইএস এ কাজ করতাম, আমরা কিউজিএস এ কাজ করতাম, আমরা তখনকার ম্যাপিং খুঁজে কাজ করেছি। সো কিছু মানুষ তারা কিন্তু নিজেদেরকে অ্যাডাপ্ট করেনি, তারা কিন্তু শিফট করেনি, তারা কিন্তু পিছিয়ে গেছে, তারা কিন্তু জিআইএস জব মার্কেটে তারা কিন্তু এগোতে পারেনি। বাট যারা ওই 2010 থেকে এভরি 5 ইয়ার্স যে চেঞ্জটা হয়েছে, যখন নতুন কিছু এসছে, নতুন ট্রেন্ড এসছে, অ্যাডাপ্ট করেছে, হ্যাঁ, এআই এসছে, অ্যাডাপ্ট করেছে, তারা কিন্তু জব মার্কেটে ভালো জায়গায় আছে অ্যান্ড ভালো পজিশনে আছে। সো ইন ইন in these conditions, you have to adapt, you have to learn, or you have to upgrade your skill every 5 to 10 years. That's the ultimate point of our discussion today. So I hope আমার লেকচার থেকে হয়তো কিছু বোঝা গেছে, বাট আমি পেরেছি। আর যদি আমার লেকচারের মধ্যে হয়তো কোনো কিছু মিসআন্ডারস্ট্যান্ডিং বা সামথিং ডিফারেন্ট বা সামথিং কিছু হয়ে থাকে, আই এম সরি, বাট আই ট্রাই মাই বেস্ট যে ক্যাচ why you are lagging behind and what we have to do, আমাদেরকে কি করতে হবে, আমাদেরকে কোন জায়গায় টাইম ইনভেস্ট করতে হবে, এন্ড কোথায় জব মার্কেট আছে। বা আমি আরো বলার সুযোগ ছিল, বা আমি সবটা বলতে পারিনি, বা সেইভাবে আমি একটু মানে প্রথমে মানে কি বলে ওটাকে ভাবছিলাম যে হাউ আই উইল স্টার্ট এন্ড হাউ আই উইল স্টপ দিস লেকচার, বাট আই উইল ট্রাই মাই বেস্ট, বাট দেয়ার আর লটস অফ কোয়েশ্চেন আই নো। Yeah, now we can discuss little bit.
Thank you, Dr. Sahana. We are very glad to have you here. The topic was very catchy and your discussion was more lively. So I think, including the students of geography, we the non-geographic peoples are also enriched by your delivery. And we can conclude the webinar within 10 minutes, but here is a interactive session. So I am inviting a few questions from the participants. If you have any question, you can type the question in the chat box, please. Jeet says, sir, PDF ta pawa jabe? He wants the PDF, sir.
Yes, yes. হ্যাঁ, আমি সেন্ড করে দেবো পিডিএফ, আমার লেকচারের পিপিটিটা, পিডিএফটা।
Thank you, sir.
Yes, Dr. Mansoor sir said, but some limitations using tools. Yes, I agree with you. There are many limitations by using tools, but we have to encourage our student, because nowadays our geography student is lacking job. So we have to encourage them to come in the modern job market. Thank you so much, sir, for your comment.
But it's my request that most of the geography students are they should give weightage to the field study also, beside utilizing all these tools and techniques. And we have to find out some loopholes also, like noting down LU and LC changes after taking spot and Landsat imageries. We should go to the field also and check out is it some anomaly or not, like checking wasteland also. During my study also, I find that some of the factory area that covered asbestos sheet are showing wasteland, but after checking it, then I find that there is a so much of hectares of land are showing as a natural or the wasteland. So there are certain checks also by utilizing all these tuition tagging, it's okay, we can go ahead, but we have to, as a geography student, it's our priority to go for the field also, field checks.
Yes, thank you.
Thank you very much, sir. Thank you. We can conclude the session. I am paying my heartfelt gratitude to you. And now I would request Dr. Jagannath Mondal to give the vote of thanks. Sir Jagannath,
Okay.
please.
On behalf of Geography Department, myself, Dr. Jagannath Mondol, as being the joint convener of this webinar, I express the vote of thanks to the all resource person, participant, and I express my sincere gratitude to the speaker, Dr. Somasis Muttu, for his in-depth knowledge about statistical technique and their application in geographical studies. Hope it will immense helps to the undergraduate and postgraduate student in a greater way. I also express my thanks to Dr. Mehboob Suhana for his knowledge about geographical opportunities and the future trends in such discipline. This also helps young geographers to get the proper guidance for their future concern. I extend my thanks to the THLH family members, especially TIC and IQ coordinator and all the teachers and all the participants and all the resource personnel to spare their valuable time with us. So I request the participant to fill up the feedback form that given in Google Meet session. It will help the generate the certificate that will send to their mail by tomorrow. Once again, I thanks to all of you for their valuable presence in our webinar, and good night to all of you. Thank you.
Thank you, Dr. Mondal. Thank you, everyone. And good night to all of you.
Dr.
Thanks again.
Dr. Bosman,
Yes,
just
yes.
I have something to say.
Okay.
First of all, thanks to all the participants for your patient sharing, and definitely our esteemed speaker, Dr. Sana. Sir, actually, a feedback link, as Dr. Jagannath said, a feedback link has been shared in the message section. Please fill the feedback link. You will all will receive a certificate by tomorrow. On certificate, you will find a QR code. By scanning the QR code, you will be redirected to our departmental website. There you can find the PDF of both the lectures, both the lecture which will be shared by our esteemed speakers. You can easily find it. You can easily find it. Okay. So once again, thank you. Okay, awesome.
Okay, thank you.
Thank you.
Feedback link is being frequently shared. Please, all the participants are requested to fill the form.